Hi, everybody. Welcome to today's webinar. We're going to talk a little bit about smart assembly in Creo Parametric. So I've just prepared a few slides before we jump into Creo. So just the agenda for today's webinar. So I'll do a quick introduction and then we're going to discuss, I think it's 2 or 3 slides before we jump into Creo and smart assembly. So just a little bit about myself. So my name's Pierre. So I'm a boundary systems technical specialist. I've been working with PTC products since 2008. So each engineer at Boundary Systems specializes in certain sections of Creo Parametric. So I'm on the manufacturing side, smart assembly, and top-down design. So a little bit about Boundary Systems. So just a slide of our offices around the world and some of our capabilities. So we are part of the PDS Vision group of companies. And some of our capabilities, we help customers with product lifecycle management, data management, CAD design and consulting, simulation, and also product development. Some of the accreditations we have, so we are a PTC Platinum partner. We're also certified implementers for Windchill and the preferred service provider for PTC. And then we can also give certified training for Creo, Windchill, MATCAD, and Arbitex. So some of the solutions we offer, so PTC are the main ones, but then we also do things like KeyShot, Moldix 3D, ZWCAD, just to mention a few. Okay, so let's jump into the smart assembly slide. So just a little bit of information around smart assembly. So smart assembly is developed by B&W software. You'll recognize some of the things that's already in Creo, things like the mold-based extension, advanced framework extension. That's currently part of the Creo installation, and then intelligent fastener is also part of the Creo 8 installation. So those are two products that you can use at the moment if you're running Creo 7 or Creo 8. And smart assembly, that's the backbone of those products. So they used something similar to that, just tweaked it a little bit for customers to also get the same effect as framework extension and fastener. And then also progressive die extension is also developed by B&W software and is also part of the smart assembly family. So what will you get when you use smart assembly? So, or where will, how can it help you? So first of all, it's giving you a nice interface. It's helping designers to be a little bit more productive, get designs out the door or onto the manufacturing floor a lot quicker. Then we can also integrate with databases. We can work with Microsoft Excel, for instance. So those all functions that's part of the smart assembly package. Yeah. So it's there to reuse information or drive the design process. There's so many different ways that you can use this. I'll show 4 small demos today where we're going to use smart assembly to design a case. Then we're going to use it a little bit on the manufacturing side where we're going to design a feature for a CNC machine. And then we're also going to drive the CNC toolpath creation with smart assembly. But really, you can use it for anything to drive a certain process or your design environment. So how would we do that? So you'll standardize on assemblies and parts, and then you just reuse that. As soon as you reuse that, there's certain rules that goes with that. How should the holes be created? Should it be tapped holes? Should it be through holes? Things like that, as a simple example. The big advantages that new users can be productive in a fraction of the time. So you don't have to teach new designers in the company how to place certain things, how to create certain features, extrudes or funny sweeps or whatever the case might be. You can sort of save that in a library and then just recall that using SmartAssembly with a user interface, and then that will guide the new guy on how to use that feature. Right? So there's a few things in the background that Creo will do to help you with that. There's also additional SmartAssembly functions that's not available in Creo. For instance, the maximum envelope of a part. It's something we can do with Creo View, but it's not in Creo Parametric. So that's a function that we can use in, or we can leverage in SmartAssembly. So SmartAssembly have a few of those functions where it will do the math in the background and then give you some output. So that's just a way a method on how to make you guys a little bit more productive with SmartAssembly. So I think that's the slide. Oh, no, there is one more slide. So the programming language that you would use is specific to SmartAssembly, and it's not really a language. You'll see the sample that I've got here. If we look at line number 12, search model ref, it tells you exactly what it's doing. We're going to search for a model reference, what the model name is and what the type is, and then that's going to be saved in a variable. And then you can reuse that to assemble components and things like that. Okay, so we'll talk a little bit more about that when we do the demo. Okay, so very simple, no previous programming experience, no compiling, and then it's also easy to go from one version to the other version. It's not in your Creo installation folder, it's a separate installation. So even if you update Creo, your SmartAssembly is not going to be affected. You just need to point it to the SmartAssembly installation, and then your new Creo version is up and running with SmartAssembly. Okay, so just a little bit about our training capabilities. So we do virtual training due to COVID restrictions. So we have all systems in place if you need virtual training. We also do in-center training. That's when you come to one of our offices, we give you training. And we also do on-site training. So if you have any training requirements, please reach out to us. And there's our contact details. So you can either reach out to me or to the sales department, and they will get back to you as soon as possible. Yeah, also be sure to visit our YouTube page. All these webinars are saved on there. So if you need to review them, feel free to go and check out YouTube site. Okay, so let's jump into Creo and let's start designing some stuff with SmartAssembly. So the first example, or the demo that I want to show you guys first, is a case where we're going to just design a case like that. So let's say that's a product that we do in our current company. There's a few variables that customers can set, and we are the new guy on the floor. We need to go and design this new case for the customer. Okay, so I've got like a little program that I run just to set up my demo setup. That's ensuring I have the correct working directory and things like that. So nothing too serious. Where we actually want to start is with the start case. So normally these little programs or icons will have a certain flow to them, and you'll see the flow that I'm going to take today. So I'm going to start off with the case, then I'm going to configure it, give it sizes and things, and then I'm going to add some hardware to it, and then at the end we're going to export the bill of material. We're going to create some 3D drawings, and we're going to export the drawing files as well. Yeah, so let's quickly run through that process. So I'm going to click on Start. So the first user interface page that you will get is, if you start, you need to provide a project number. So you can see this one is in red. So I'm forcing the user to give me a project number. I'm just going to pick some random number. And then also I can pick a case style. So we have various styles that we can use as start points. Right, so what we do with this, as soon as I pick a certain style, that will grab a certain template in the background. It will create certain drawings. So everything is dependent on the style that I select here, and you can sort of breach that out to different things that you want to accomplish. For instance, in this type of case, I can only use that handle. In this type of case, I can use handles like in the picture here, or I can use straps or things like that. Okay, so there's design rules that you can capture, that you can force with SmartAssembly. Okay, so we're going to go for the B style, and we're going to pick whatever material we want to use. Do we want to use oak or stainless steel or sheet metal or whatever the case might be? So I'm going to go with pine, and I'm just going to say, well, okay, that's my selection. And then we're going to go into the configure case user interface. So here's a few things that you can add here. So we've got some variable dimensions that we can set. So let's change this one to 45. And then you'll see there's a warning sign, and it defaults back to 40. Okay, so in this particular dimension, I have a maximum length that I can set, and that is 40. So a designer can't create something that's out of specification for the manufacturing guys. Okay, so rules like that you can build and force designers to stay within certain design parameters that's driven from the manufacturing side. And then obviously you can go and change all the other dimensions if you need to. And then you'll also see it's calculating the volume of the case as you change those dimensions. Okay, so I'm going to stay with those values. We can also pick a color if we want to, and you can see the interface updates each and every time we do that. Now I'm going to say okay on that, and now Creo is going into the background and it's building that case for me. So you can see we're missing a few things here, latches, we need to protect the corners, things like that. So let's go and add that hardware. So you can click on the SmartAssembly tab. So as soon as you install SmartAssembly, you'll have this extra tab. And when you call these little program or these little instructions, you're going to use the create new component. You'll see I've added that to my quick access toolbar here at the top as well. So I don't have to click on the tab and over here each time. I can just start the new component here from the top. So if you see me picking there at the top, that's what I'm doing at the moment. Okay, so let's go and add some corners. So we've configured our case. Let's see what corners we can add. So we've got a whole variety of options that we give our customers. We're going to stick with this one over here, and then we can tell SmartAssembly where to add those corners. You can see in red, it's going to add them to the lid and to the bottom. So if you unpick one, you see they're not showing at the lid, they're still showing at the bottom. And then I can also add it to the lid. Okay, so in this case, we're going to do both the lid and the bottom. And you'll notice that SmartAssembly assembled all of those on the corners. Okay, so once again, that is design rules that's in there. We tell it to go and use certain references to place each of them, and it will go and place them automatically. So again, making you guys a little bit more productive. If you have to go and select the references for these 8 components, maybe for 8, it's not that bad, but if you have to build 20 cases a day, it becomes a little bit cumbersome. So that's where SmartAssembly fits right in. Okay, so the next one that we need to add is some handles. So we have a few options on the handle. So we're first going to go and add some straps. You'll notice it's picking up the case length in this user interface. So it's measuring the case and the height of the base. And it tells me I can only add 2 handles at the moment. And I'm going to put those 2 handles on the side panel. So let's quickly do that. So you can see the strap handles are in place and the holes are also there for the strap handles. So where the standardization comes in a little bit here is it's always in the center, it's always a certain distance from the top. So those are all design rules, design intent that you've captured with SmartAssembly. So a new guy can't go and place that handle here in the middle of the side panel. He's forced to place it where it needs to be, where a senior designer sort of said, this is the company standard, we place handles over there. And then one of the other things that you can do is you can remove handles and you can tweak your design if you need to. So we're going to add a different type of handle, and that's going to give us different options. So you see now our default value is still 2 handles, but our maximum number of that particular handle now is 4. So we can add 4 of those handles. So let's keep it at 2, and then we're going to come back and change that as well. So let's see where those handles fit in. Now once again, in the middle, certain distance from the top, and we already have that cutout for that handle type. So that's a part level cut. So if you go and open up that component, then you will see that cut in there. So you know drawings and everything will line up. Let's go and remove this. And let's add 4 handles. It said we can add 4. So let's do 4. And let's just see what's going to happen with 4 handles. Yeah, so it's 2 aside, 1 at the back. So once again, design rules coming into play, certain distance from the back and from the front. Okay? And that's a company standard that was just captured there. Let's remove that again. Now I've got one more thing to show you guys on the handles. So let's going to stay with 2, and then I'm going to say, well, I'm going to do something odd. I'm going to put handles on the front panel. Okay, and then we say, okay, so handles on front panels is not supported. So nobody can put handles on a certain section of your design where it's not allowed. Okay, so once again, capturing that design intent, making designers more productive, capturing that information. Okay, so let's go and see where we can add handles. Can we add handles on the rear panel? Okay, so yes, we can add handles in the rear panel. So we can accommodate our customer there. We can't do it in the front, but we can do it in the back for him for whatever manufacturing reason there might be. Yeah. And we've added those handles in there. Okay, so let's keep those handles in there. Let's look at the next step that we need. We need to add locks or catches. So let's add the catch. We need to close this. Yeah, so that's the type of catch that we wanted. So you can see the hardware is being added in there on the bottom case and into the lid. So now we can close it up. We protect the corners, and we have handles to carry this. Okay, so what the next step would be, if we wanted to add locks, we can. It's exactly the same as the catches. If we wanted to do interior things, there's certain rules for that as well, and programs that we can use. What I want to show you guys is the next step where we add a nameplate. So you quickly need to identify the case. So you can give it parameters. So what's the name? So I'm just going to call it webinar, and then my initials, something like that. And then where do you want to place it? Do you want to go and click where you want to place it, or do you want to use some of the predefined options? So we have top left, top right, in the center, bottom left, bottom right options here. So we're going to go smack bang in the middle. And we're going to say OK. And again, so it's using that name tag. It's a standard component. It's a library component. We're pulling it from the library. We're assembling it. We're creating the holes for where it should be in our top panel, and these little cutouts to fit the name tag in there. Okay. So we've got a name tag. Let's say the design is finished. So now we need to give the manufacturing guys something. So we have a few options. So we can give them Excel spreadsheet bill of material. So I'm just quickly going to run that. And I'm going to say, well, let's do the full assembly. So there's certain options when you export this to Excel on what do you want to take to that bill of material. So it's going to open up Excel. And once you're on Excel, the Microsoft world opens up to you, and you can manipulate and do all the fancy stuff within Excel. You can apply that to this bill of material. So you're going to save that and just reuse that. Okay, then the next one is creating a drawing. So there's two ways that we can create the drawings. I'm just going to show this one quickly. So we have a few export options. So the Creo drawings one is part of the export. It's going to create the Creo drawing. The parametric link between drawings and assemblies will still be there, but we can also do step files. We can do 3D PDFs. We can do shrink wrap parts. We can do PDF drawings if we want to. So you can choose whatever you want to do there. So let's quickly go and create that drawings. So you can see standard PTC or Creo Parametric stuff. So as soon as you have that drawing, once again, you can go in there. You can create different sheets. You can add the latches. The bill of materials already there. You can add notes and bits and pieces like that in there. The other one that I wanted to show you is the 3D drawing creation. So the 3D drawing creation is that model-based definition that we currently use within Creo. So everything is on the 3D side, and it's going in the background, and it's creating all of that information for us. Okay, so it seems like I have a little bit of an error on this particular so a movement of the annotation failed yet, so I just have to go and add that. So let's just see. So it did create the panels for me with some information in there. Obviously, it didn't do everything at the moment. Then we also still have our default view. Let's quickly go and view that drawing that I've created. Okay, so we still have our 2D drawings with our bill of material. We still use normal formats like you would do with normal Creo Parametric drawings. We're just pulling this information from a library, the templates and things like that, and then it's adding that. So from here, you will basically save this, and then you have your design or your variant in there. Okay, so that's what I wanted to show you guys on the case demonstration. So I'm going to close this out, and let's jump onto a new scenario. And the next scenario is where we need to design a feature for machining. Okay, so once again, I have this little demo setup program that I run. It's just opening up a component and setting my working directory to where it needs to be, and then displaying some information Okay, so this is the part. So we need to put this onto a CNC machine, and we need to hold it down somehow. You can see it's a casting component. So let's see how we can use SmartAssembly to make that whole process a lot easier. So we're going to go into SmartAssembly. Our workflow now would be, we need to specify a machine, then we need to specify some hardware to keep all of this down. Then we need to give the guys on the floor a bill of material to let them know what type of clamps and locating pins and things they need to use. Okay, so first that we need to specify is the machine that we'll use. And once again, I'm forcing project number, so I know that the plate that I'm going to machine will be specific for this component. Then I can sort of pick the machine type that I want. So we have a Bridgeport, a Haas, and a Mozart machine. So all three machines have different tables, the table sizes, different plates that we need to specify. So depending on my selection here, that will bring in a different base plate. So I'm going to do this on the Bridgeport. And let's just have a quick look at what happened in the model tree. So we've assembled the Bridgeport base. Then we have the plate that we're going to machine. And then we have the part that's going to be the end product to the customer. So the thing that we're going to focus on now is this orange plate. So we need to machine holes and bits and pieces where we're going to keep this this casting component down. Okay, so we need to clamp it down. So what clamps do we have to that we can use? So the first one is the center clamp, and the only thing that I need to specify is the datum axis. It knows it needs to go and sit on top of this plate, and then holding that part down for us. Yeah. So that's going to put it right in the center. The next thing we'll need to do is use some of these vertical clamps. So we've got a few options on how we want to space them. So I'm just going to put them, we're working with the round part. So I'm going to use the radial option. And notice that there's a few things that are going to happen once I pick my surface. So I'm going to pick a surface over here. Then I'm going to say, okay. So in the background, SmartAssembly looked for the closest edge, and you sort of offsetted that and then placing that clamp over there. So that clamp length and everything lines up with holes that's being created, and we have some spaces in here as well. So if I go and I say I want to place another clamp, I pick a surface that's a little bit higher. Notice that I have a few more washers in here, or spaces. Let's clamp one on this side. I think if we grab it over here, we should be able to hold this down and machine the inside of this or certain sections. Maybe that pick wasn't that great. It should have been more to the center. That's okay. The toolpath will jump over that. Okay, so now we've got our clamps down. So the next thing that we'll need is just the locating pin, just to so this part can't turn certain degrees, and then everything's going to be out. So let's just locate that. I'm going to put the locating pin over here, but once again we have a little program for that, and we're just going to pick the locating pin. And notice the interface now. Also notice what happened in the background. The base plate and everything was hidden as soon as we activated this. Only the manufacturing part is showing at the moment, making selection and things like that a lot easier. So what do we need to select? We need to select the placement axis and then the inside surface. So let's pick the center axis, and then let's pick the boss surface, and we're going to go back and we're going to see our locating pin being assembled, and we have the hole in the plate. Okay, so let's say that's all we need to hold this part down. I just quickly want to take this base plate and hide that, just to show you guys what happened to this plate. So all the holes and everything was created for these center pins, the holes for the clamps, everything was created for us. So there's no way that we can go and drill these holes in the wrong place. We know it is 100% for this clamp type. Okay, so the next thing we need to do is to go and create the drawing for this plate. So somebody needs to put it on a machine and drill those holes. Now that I've seen the hardware, I forgot about one thing. We need to hold that plate down to the machine table. So let's quickly go and add some TBolts. So notice that I'm just going to pick on a surface, and then it's sort of lining it up automatically with the T-slots. Okay, so that's because those references were specified in our program. Whenever I pick it, it's going to look for the closest one, and then it's working from an offset to place that. Okay, so let's do one in the middle, and let's do one on the side. And we can do the same for the other side, but I'm just going to do, let's do that one, just so we have something funny. Yeah, so we have something like that. Okay, then always you can go back and you can add more if you need to, or do whatever you need to keep that plate down. Okay, so let's go and create that drawing. So once again, now you can see our template here don't have a format. So it's just giving us real basic information. We just finish up. Here we go. So there's our drawing. So we've got dimensions from a side for guys to go and easily pick that up. Then we've got a second sheet. It's also giving us some information from one side, so different dimensioning schemes. Then we've got a hole table. So depending on a certain coordinate system where those holes are located in X and Y values, and then what type of hole it is. And then lastly, we've got the 3D view of our feature plate as well. Okay, and then we have our bill of material in there. So what type of lock washers we used, what type of clamps we used, so all of that in there. So the guys can just go and machine that part and then know our product will fit on there for CNC machining. Okay, and that brings me to the CNC part of the smart assembly demonstration. So let's quickly jump into that. So I'm just going to erase my memory, and for this one I have to select my working directory. I'm just going to set that. And then we're going to start our manufacturing. So we've got two, well, you can do it any way you want, or we can customize this to fit your needs. This is just a demonstration on how to get everything started. So in this example, you're going to pick your reference part, and then you're going to place that with the coordinate system. That's going to put it inside Creo. So all your default parts, your templates will have certain coordinate systems, and that's how that will link up within this process. And then notice what happened in our model tree. So we've assembled our reference part, the part that we want to machine. It created a machine for us. It created an operation for us, and then it also created this this mill window for us. Okay. So all in one go. it created all of that. So in this scenario, you would only have one type of machine. Different scenarios, you will have many types of machines, like I used in the feature demo, where you have Haas or Bridgeport or Mazak or Moriziki or whatever the case might be. Okay, so depending on your circumstances, you customize this process to fit your needs. Okay, so let's go and machine something. So we've got the setup right, we have everything. So now we can just go and machine. So I can click on the Smart Assembly again, or you can add that create new component shortcut, and let's just do a quick process. So quick process, you sort of pick what you want to do. No roughing, just a quick rough, or roughing, re-roughing, standard finishing. You pick what you want. So I'm just going to do a quick rough. So it's giving me some parameters that I can fill in. Okay, so that's just offset, step depth, and so on. I'm going to say OK. The next thing that I can choose is the tool that I want to use. So we have some predefined tools in our library. We set that up. And it's going and it's creating that quick process for us. So you can see there's the quick rough in here. So let's play that tool path. So I haven't set any parameters for any tooling. All of that was done previously on trial and tested, cutting speeds and feeds and cut depths. So I know this is right. I can put this on the machine with confidence. A new guy doesn't have to worry about cutting too fast or too slow or with the wrong cutters. Everything is there. And there's our tool path. Okay, so that's just a roughing tool path with a big ball cutter. So if we go back into our Smart Assembly, we can go to quick interface again, and we can pick, we want a certain finishing thing, and then we can pick that. We can go through the same scenario. So whatever I pick here is going to be exactly the same. What I want to show you guys is the other method where we have certain toolpaths that's specific to certain scenarios. So once again, this is now where you can break it up a little bit. So we've done the roughing. We sort of used the quick roughing, but in that process. So let's go for a finishing. So in the finishing, we use that 12.7 cutter, that's millimeters. So I'm going to run a finishing toolpath with the 12 ball cutter. I'm going to keep my angle at 0, but I'm going to leave a little bit of stock in here. I know those radius are smaller than that, so I'm going to leave something on there. And then I need to pick a mold surface. So luckily with the quick process, it already created that mold surface for us. So we can leverage that and just say OK on the surface machine. And you can see surface finish is, yeah, so quickly play that. And we sort of have a roughing cycle and a finishing cycle. So those two processes are ready. Load the part onto machine, get it going with the roughing and the finishing while I'm busy programming the other small bits and pieces. Maybe we need to finish up these corners here, so I can quickly do that while you're setting up the machine. Okay, so the next step, the next thing that I want to show you is how we're going to do that. So in Smart Assembly, there's a few nice tools. So I'm just going to add that to create surfaces and things for you very quickly. And the one that I want to show you is the mold surface. So mold surface, it's just going to recreate the one we already have. So that's not really going to show us anything at the moment. The one that I want to show you is this mold surface tangent. So we're going to set a value. So that's sort of like an accuracy value where it's going to look for tangency between surfaces. If I put 100 in here, it's going to pick the whole part. It's going to go over these sharp corners, and that's maybe not something we want. 10 is fairly accurate, so I'm going to leave it at default. And we're going to pick a surface, and we're going to pick this one over here. And now Smart Assembly is going to go in the background, and it's going to look for all the tangent surfaces. Okay, so you can see I've picked that one. That surface was tangent to it, that surface was tangent, and then it grabbed all of those surfaces in one go for us. Okay, so if we want to run a finishing path on those surfaces again, very easy. We go and we say, well, we've got the toolpaths, we want a finishing sequence on that, but this time we're going to use a 6 ball nose cutter. We're going to leave a little bit of material on again. We're going to pick that surface. We're going to say finish that. And now we have a toolpath only finishing that particular surfaces for us. Okay, so great, quick and easy. Let's say we have surfaces we don't want to machine. Okay, so let's just quickly look at the model tree. So how did Smart Assembly go and create those surfaces? So it used the copy geometry feature, and then it sort of converted that to a mold surface. So all we need to do is edit definition this. Keep in mind we're using Smart Assembly to create things for us, but we're using Creo Parametric functionality. So you can go back and you can change that. So if I go in there and I say, well, I don't want these surfaces on the side, you can quickly go and remove them from that copy geometry. And say, okay, and now you only have those surfaces that you want to machine. Let's quickly recreate that, and now we're only finishing those surfaces. Okay. Again, using the correct speeds and feeds for our 6mm ball cutter. Yeah. And that rule applies to all the cutters that you might have in your assembly. Okay, so we're running a little bit out of time. I wanted to show you guys a different method of creating the NC stuff. So I'm just quickly going to talk you through that. Let's quickly go into Smart Assembly, and let's go into the other NC demo. So you'll see this process here have a few steps. It's doing a lot of the thinking work for us. In this one, it's not doing that much for us. So let's just start it, and then you see. So here we can pick a manufacturing name again. We have an option between millimeters and inches now, and we also have an option between 4-axis and 5-axis machines. Okay, so this is just a different way that you can approach your manufacturing, and it all depends on what's available on the manufacturing floor. Okay, so it's loading that template for us, renaming it, and then just giving us a machine. Okay, so I've picked 3-axis machine. It's giving us a 3-axis machine. In the other examples, we had an operation. We had a mill window already there. We had predefined toolpaths we can use. So you can sort of customize all of this for your needs and your or the experience that you have on the programming side. So let's go and let's just pick our workflow. So we need to add a reference part, we need to add a workpiece, we need an origin for our G54, and then we need to specify a safety plane. So let's do all of that. So this is the sample part that I'll machine. I'll pick the coordinate system. So we have a G54 standard coordinate system in our start parts. That's what I'll use. Next step is create a workpiece. So how do we create the workpiece? Do we want to assemble a workpiece, or do we want to let Creo create that one for us? And keep your eye on this info here. It's going to go and calculate how big that part is. Okay, so there's our length, width, and height. We want to add a little bit to our Z value for a surface finish cut. So Okay, we add that. So there's our stock material. So where do we want to make our pickup for this component? So it's going to be X direction on the machine for that edge, the Z direction for that edge, and then my top plane is going to sit over there. I'm going to say okay. The next thing I need to specify is a 10mm safety distance from that particular surface. And then we have our setup. Okay, so now we have our part in there, we have origin, and we have a safety plane. We don't have an operation and things like that. Things that was automatically done in the previous example. So let's quickly go and create that. So now we need the operations. So what do we need to add? We need to add an operation, and then we need to add a milling window. That was also done in the previous one automatically. Then we need to add an NC sequence, a roughing or finishing or anything like that. Okay, next thing we need to specify the mold window surface. So this is going to be different for all your parts. So you'll see what's going to happen to this particular part now. Just need to add a value in there. So it created the operation for us and the mold window. Something is wrong with the mold window. That's okay. We're going to go back and fix that up now. So what type of sequence do we want to add? A roughing, re-roughing, or finishing? Just going to do a roughing for now. What tool do we want to use? Tool 1 is a 10mm tool. So you see now I don't have specific descriptions for my tools. The previous one had nice descriptions. So once again, it depends on what you guys want to see. T01 is normally the first tool in the machine. T2 is the second tool in the machine. T3 is the third tool. And as soon as you pick on them, you can see what tool it is. So that's a 5 diameter, a 2 diameter. So that's going to be too small. We're going to work with the 10 diameter. We need to specify the mold window. And we're going to say, okay. So that roughing sequence might give us a little bit of an issue now because that mold window is not complete. So I'm going to work through this and let's see if we can go and change the mold window afterwards. So I'm going to do a constant load cut. So there's a sample of that cut. Then I'm going to do a ramp, and I'm just going to do a ramp on a 5-degree angle. I'm going to go okay. Step overs, step depth 10 for 10 cutter. It's a constant load, so it should be fine. Step over 5 might be a little bit too much. Let's change that to 3. And then stock allowance, we want at least 1 millimeter on here. And then it's going to copy the speeds and feeds from the tool. You see we have those options. If we untick that, then we need to specify that. Okay, so once again, a method of knowing that the correct speeds and feeds are used for your cutters. I'm going to say okay there. It's going to create that. And it's going to create the roughing sequence, but this mold window is not right. So by default, we normally say we need to keep the inside edges, but for this particular part, we don't need that. So once again, just an example of editing definition, you being able to manipulate whatever you've done with SmartAssembly within Creo. So you can manipulate that whenever you want to. Say okay. And then we can play our roughing sequence. And we have some TBolts. Okay, so the next step would be to output that to the machine. You can write the program for that. It's a few clicks within Creo. It all depends on how far you want to take that with SmartAssembly. Okay, guys, so that's what I wanted to show you within Creo and SmartAssembly today. I'm going to mute myself for a little bit and give you time to ask some questions. So on the GoToWebinar pane, you can there's a question section. get those questions into me, and then we can quickly have a discussion around that. If you want to take a quick snapshot of our contact information, feel free to do that. Hey guys, so I don't see any questions coming in. If you have any questions or you think about questions, please reach out to us. You can send me a direct email. I'll respond to those as soon as I can. Alternatively, you can reach out to the office and somebody can help you there. But with no questions, I'm going to go ahead and end the webinar. Please go and visit our YouTube site. This one will be uploaded as well for you guys to review. Again, thank you for watching and see you next time. Bye.